Welcome to another audit walkthrough video from SuperfastCPA. I'm Logan, and in today's video, we're going to be in Audit Area 3. This is our first video for Audit Area 3. This is Section A1. This is a remembering and understanding topic. Explain the components of a relational database, and that would be things like tables, records, fields/attributes, primary and foreign keys, and normalization. And we're going to be doing that the SuperfastCPA way, which is diving straight into the questions to learn the material. Now, if you don't know much about our strategies, make sure you go to SuperfastCPA.com and sign up for our free 1-hour webinar training. Again, it's free, it's 1 hour, and in that 1 hour, we will teach you the key ingredients to passing the CPA exam so you don't waste months or even years of your time failing exams. So make sure you check that out. And after you check that out, you're going to want to learn more, so make sure you also check out becoming a SuperfastCPA Pro member. Now, in today's video, we're only going to be going over 5 questions, and to be honest, we're also only going to be going over 5 questions for the member version of this video. But typically, SuperfastCPA Pro members get access to the full 10-question versions of these YouTube videos so that they can get a little bit more practice and a little bit more understanding. Now, with this video, this is a pretty straightforward topic. We're really just kind of defining these things so that you know what they are. So I felt like it wasn't really necessary to do a full 10-question version for the members compared to the 5-question version for YouTube. But typically, SuperfastCPA Pro members get access to that full video so they can get a little bit more practice and a little bit more understanding. Now with that, let's dive into the questions for this video. All right, here we are at question 1. And this is going to be a pretty quick video compared to a lot of the other ones because, like I said, it's pretty much just a definitions video. We're learning about the different pieces of a relational database. So let's dive into question 1. This shouldn't be too difficult. Which of the following best describes a relational database? So if you don't know what that is, let's start learning. Option A, a system that stores data in hierarchical structures with parent-child relationships. Option B, a collection of related data organized into tables with structured relationships between them. Option C, a method of storing data in a single large file without defined structures. Or option D, a type of database that primarily relies on key value pairs for data retrieval. So if you don't know what a relational database is, that's okay. We're going to use this question to learn what it is. But basically, we're kind of diving into the realm of data analytics for this video and the next few videos. So if you don't really know what this stuff is, again, that's okay. We're going to use this question to learn. So let's dive into the explanation. All right, here we are. The answer is B, a collection of related data organized into tables with structured relationships between them. So that's the idea behind a relational database. So let's read the explanation to understand it a little bit better. A relational database organizes data into structured tables, and we've probably all seen tables in accounting, where relationships between the data are maintained through keys such as primary and foreign keys. And we'll learn more about those in the next few questions. This system ensures data integrity, minimizes redundancy, and allows for efficient data retrieval using structured query language or SQL. Unlike hierarchical or key value databases, relational databases use predefined schemas to establish clear relationships between different data sets. So basically, relational databases are basically a database of tables and things like that, structured tables, and how those tables connect to each other and how that kind of all becomes a database of its own, so you can kind of see how different pieces of information flow together and how they work together. So that's kind of the general idea with a relational database. Now let's go to the next question. All right, here we are at question 2. How do tables and records relate to each other in a relational database? So let's go through the options. Option A, a table is a single entry of data, while records define the structure of the database. Option B, a table stores multiple records with each record representing a single instance of data. Option C, tables and records are the same and the terms can be used interchangeably. Or option D, a record consists of multiple tables, each storing different categories of data. So if you don't really know, I mean, we kind of talked about what a table is, and again, we've all kind of seen what tables are in accounting. But if you don't know how a table relates to a record or what they really are, that's okay. We're going to learn about that in this question. So let's dive into the answer. All right, here we are. The answer is B, a table stores multiple records with each record representing a single instance of data. So to kind of clarify what I'm meaning there, in a relational database, a table is a structured collection of data organized into rows and columns. Again, we've all kind of seen this before. That's pretty much what a spreadsheet looks like. It's just one big table, and you can, of course, make actual tables out of it with rows and columns. Each record is also called a row. Within a table represents a single data entry or instance. For example, in a customer's table, each row or record contains details about an individual customer, while the table itself holds all customer records. So the idea there is the table, again, we've all seen that before, has rows and columns so that you can kind of keep track of different things, different customers, different products, whatever the case is. And each row in a table is a record. That's what a record is. So I think we kind of understand that pretty easily. Now let's go to the next question. All right, here we are at question 3. which component of a relational database is best described as a specific category of data stored in a table with each record containing a value for this category? Okay, so if, again, you don't really know what that means, we talked about a table and we talked about a record so far, so you could probably kind of assume that we're not talking about that right now. And also, this doesn't really sound like, it's using table and record in the definition of whatever we're talking about. So probably not those two. You can kind of deduce that. So it's probably either C, a field or attribute, or D, a primary key. If you know, that's great. If not, let's go ahead and look at the answer together. All right, here we are at the answer, C, field or attribute. That is what is being described. So a field or attribute, again, kind of going off the question, and then we'll read the explanation, is a component of a relational database, and it's best described as a specific category of data stored in a table with each record containing a value for this category. So that's what a field or attribute is. So again, let's read the explanation to kind of understand it a little bit better. A field, and it's also called an attribute, they're kind of used interchangeably, is a column in a table that stores a specific type of data for each record. For example, in a customer's table, fields might include name, email, and phone number. Each record, and that's the row, remember, in the table contains a value for these fields, ensuring a structured and consistent data storage. So you're kind of getting the idea here. In a table, the row or the record is, a customer or whatever it may be. And the columns or the fields or attributes are the different things about that record or about, that customer that people need to know. This is their name. This is their email. This is the date they started with us. Whatever the case is, that would be the field or attribute. And each record can have, obviously multiple fields or attributes, because you can have one row that has a whole bunch of columns connected to it or a whole bunch of fields or attributes connected to it. So again, we're learning pretty simple stuff here, but this is kind of like basic stuff that we need to make sure that we know for other things about data analytics. Now let's go to the next question. Okay, here we are at question 4. Which of the following best describes the difference between a primary key and a foreign key in a relational database? So if you know what those are, that's great. If not, let's go through the options. Option A, a primary key uniquely identifies a record in its own table, while a foreign key links to a primary key in another table. Option B, a primary key allows duplicate values, while a foreign key must always be unique. Option C, a primary key stores the actual data, while a foreign key only references the table structure. Or option D, a primary key is optional in a table, while a foreign key is required in every table. So again, if you know the difference between a primary key and a foreign key, that's great. But if not, let's kind of dive into the answer to learn what these are. All right, here we are at the answer A. A primary key uniquely identifies a record in its own table, while a foreign key links to a primary key in another table. And that's the general idea. Of course, we're not diving extremely deeply into this, but that's the general idea right there that you need to know about this for the CPA exam. A primary key is a unique identifier for each record in a table. So that would be something like a customer ID in a customer's table. A foreign key is a field in one table that references the primary key of another table, creating a relationship between the two tables. So that would be something like a customer ID in an orders table linking to the customer's table. This ensures data integrity and prevents orphaned records, or basically keeps things from getting lost and keeps things connected so that, you can connect this customer's order in the order table to the customer's table so you can kind of know the attributes of that customer in the customer table. So again, primary key is just a unique identifier. A foreign key is something that references a primary key in another table, again, creating that relationship. With that, let's go to the next question. All right, here we are at question 5. What is the primary purpose of normalization in a relational database? So let's walk through this. Option A, to increase data redundancy for faster queries. Option B, to organize data efficiently by reducing redundancy and improving consistency. Option C, to store all data in a single large table for easier access. Or option D, to eliminate the need for relationships between tables. Now, if you have no idea what normalization is, that's okay. We're going to look at the answer in a second. But if you kind of have an idea of what this is, pause the video and think through this so you can kind of pick the correct answer. And when you're ready, come back, we'll look at the answer together. All right, here we are. The answer is B, to organize data efficiently by reducing redundancy and improving consistency. So we'll just go over the simple definition of normalization. Normalization is the process of structuring a relational database to minimize redundancy and improve data integrity. This is done by breaking large tables into smaller, related tables and using foreign keys to maintain relationships. For example, instead of storing customer details in every order record, a customer's table can store this information, and an orders table can reference it using a foreign key. This ensures consistency and avoids duplication. So again, essentially normalization is a way to structure a relational database so that you don't have to repeat yourself over and over again. You can kind of break your information into multiple tables and have them connected. That's the point of a relational database, having these relationships between tables so that, again, you can kind of have different pieces of information in different places instead of in one massive table or one massive database or list. So with that, we've gone over 5 questions to learn about a few different things in relational databases. Before we do anything else, let's do one more part of the SuperFast CPA process called pillar topics. Now, the idea behind pillar topics is as you're going through the questions to learn the material, you will notice the things that keep popping up. You've seen 2 or 3 questions trying to teach you what a relational database is, or what a primary key is, or whatever the case is. You notice these things and you write them out in your own words as the pillar topics of what you learned that day through the questions. And as you're doing this each day, you're building your own personal repository of the most important things you learned from the questions so that you're ready for the exam. So let's go ahead and take a look at the pillar topics for this video. All right, here we are at the pillar topics. Again, this video is pretty simple, pretty straightforward. We're just basically talking about definitions here. So let's dive into these definitions essentially. Relational database. This is a structured collection of data stored in tables, where relationships between data are maintained using keys. And so this would be an example of a customers table that's linked to an orders table by a customer ID. That's kind of like the idea behind a relational database. You're linking all these tables and all this data together. Now let's talk about tables and records. A table stores data in rows and columns, while a record is a row, and this represents a single entry in the table. So an example would be there's a products table, and then each row is a record, and it represents a different product. So that's the idea behind tables and records. Now let's talk about fields and attributes. A field or an attribute, again, they're the same thing, is a column in a table that stores a specific type of data. So that would be things like a customer's table having fields like the name, the email, or the phone number of customers. So the customer ID would probably be the record, and then their attributes would be the columns, and that would be their name, email, or phone number. Now let's talk about primary and foreign keys. A primary key uniquely identifies each record in a table, while a foreign key links to a primary key in another table. And again, same example as we talked about before, this would be an example of a customer ID that's a primary key in the customers table being a foreign key in the orders table, so that in the orders table, you can connect all of these orders to this customer that is in the customer table. Now let's talk about normalization. This is the process of structuring a database to reduce redundancy and improve consistency by breaking data into related tables. So the example of this would be storing customer details in a customer's table instead of repeating them in an orders table. So imagine, you had an orders table, and every single time a customer placed an order, it listed out all of that customer's information for every single order in that order table, because the same customer can place multiple orders. So you would just have the same information repeated over and over and over again. Whereas instead, if you have all that information for that customer in the customer table, all you have to do is link with the foreign key in the orders table to the primary key in the customers table. And then you just have that key for every order instead of all the information for every order that the customer places. So I hope that you're kind of seeing why you would do that and hope that makes sense. Now with that, we've learned a lot in just 5 questions and in the pillar topics, and that is it for this video. Remember, in this video, we're only going over 5 questions in the YouTube version and only 5 questions for the member version, because this is a pretty straightforward topic, just kind of some basic definitions. But remember, SuperFast CPA Pro members typically get access to the full 10 question versions of these 5 question videos, so they can get a little bit more practice and a little bit more understanding. So if you like this and you like our other videos, make sure you check out becoming a SuperFast CPA Pro member, because you'll get access to a lot of great stuff. Not only the pro course where Nate explains exactly how you're supposed to be going through the process, but also the multiple choice question walkthrough videos that have the full versions. And the easiest way to learn about becoming a SuperFast CPA Pro member is actually going to superfastcpa.com, signing up for the webinar. That will teach you a lot about SuperFast CPA in general, and then that will give you a good path to signing up to become a SuperFast CPA Pro member. So check out the webinar, check out becoming a pro member. I hope this video was helpful. Thank you for watching. If you did like it, make sure to like it and leave a comment, and I will see you in the next video.